All right, let's first start with cubes. Okay, we should be familiar with squares, right? 4 squared is no different than 4 times 4, which is going to give us 16, right? Okay, so a cube is just 4 to the third power, which is equal to 4 times 4 times 4, which is going to give us 64. That's correct. Okay. So cubes are nothing different other than adding, or I shouldn't say adding, but multiplying by the base number one more time, right? So you would have 6 squared is equal to 6 times 6, which is equal to 36. And if we cube it, that's 6 times 6 times 6 is going to give us 216, right? Okay, anytime that you exponentially multiply it, it's going to get larger really, really quickly. So just realize that, right? The larger the exponent is, the more gigantic the number is going to get quickly, right? Okay, so we're okay with the cubes, yes? I mean, it's pretty simple, basic math. Okay, let's talk, bless you, cube roots. Bless you. Okay, so just as a refresher here, over here to the side, we had our square roots, right? We had, square root of 4 was 2, right? Square root of 16 was 4, right? And 2 and 4 are called squares. Okay, when we're dealing with cube roots, it's just a little bit different in the sense that, remember what that was called? Where the arrows are at? What's that called? Brady? Okay, no. No. 64 is the radicand. The symbol itself is, okay, it's yeah, most people say it's the radical sign. Even though you could say square, you could say it's the square root sign, but if we're talking cube roots, you would probably want to use the radical sign more because when you say square roots, most people think of obviously it's something that's square. Now, the only thing that changes is since we're dealing with cube roots, how can we differentiate between the green and the red here? We got to put a little 3 here where the little check goes. Okay, there's a little 3, hence cube roots. It's a 3. Okay, that goes right in the little groove there where the radical sign goes. That's the way that you can tell the difference between a square root and a cube root. Okay, so these are just a hair bit harder, just for the fact that you now, speaking of the cubes, you now have to think of 3 numbers multiplied together that is going to give you the radicand, not just 2. So it is a tad bit hard. Now, I will show you something here in a minute, but the good news is you're going to be able to use your calculator. Well, it's a little different calculator, okay, because your 4-function calculator doesn't have cube roots on it. Right. No big deal. We'll show you here in a minute. Okay, so if we were to find the cube root, right, your thought process should be, okay, what multiplied together by the same number the radicand is going to give you, and that's going to be 4. Because we just did that on the previous page, right? 4 times 4 times 4 gives me 64. Bless you. Okay, does that make sense? Okay, the harder ones, and again, you'll be able to use your calculator, but when we start getting into, it might look easy. Cube root of 512. Now, those are tough to do unless you do these all the time. I'm not going to lie to you. They're tough, and that's why we're going to let you use your calculator. That's not a problem. Cohen, did you have it? What do you got? Yeah. It's 8, right? 8 times 8 times 8 is going to give you 512. Because you got to realize you get 8 times 8, that's 64. Now you got to take 64 times 8, and that's going to give you 512. Okay? Whatever you do, don't divide. It's not going to give you the right answer. All right, so far so good. Are you sure you're awake for this next one? Well, we're going to find out. All right. Might want to write these down, by the way. Okay, the one on the left. What's our answer? See who was paying attention last week. Michael? Michael says 2. Oh, I still have hands up. Emma. Thank you, ma'am, for listening. That is an imaginary number. It does not exist. Okay? It does, but it doesn't. There's no numbers to them. There's no number that you can come up with. Because of what is a square? You have to multiply something by the same number to get the radicand. Right? There's no two numbers. -2 times that's not going to give me -4. A +2 and a -2 isn't going to give me a negative. It's not going to happen, right? It got to be the same number. Correct? Those are imaginary numbers. Now, when we have cube roots and a negative on the inside, right? Now let's go backwards here. Oops. What about this? You should know the answer to this. Oops. What do we got now? Grayson? Okay, here we can come up with -2 because the negative's on the outside. Very good. Remember, you had that on your quiz, actually. Okay, what about cube roots? Are those imaginary numbers? Or can we get a numerical answer here? This goes back to chapter 1, by the way. What do you think? Benson says an imaginary number. Logan, what do you think?
It is not an imaginary number.
All right, what's the answer? Zach, what were you going to say? Okay. Squares, we got to come up with the same two numbers multiplied together, right? Well, what's -5 times -5 times -5? -5 times -5 is a +25, yes? Times a -5 is a -125. Absolutely, you can have a negative cube root. That's not a problem. Why? Because we can come up with the same numbers. Has to be the same numbers. You can't come up with the same numbers with -4 when you come up with squares. Okay, everybody good with that? All right, you see the difference? Okay, between a negative square root and a negative cube root. Logan, were you going to say something, bud?
I'm going to say that you can't have a negative inside of any even root.
Correct. That is good. You cannot have a. That is correct. The number underneath, one quick way. Go ahead, Logan. Say that again for him. You're right.
The number on the inside of the radicand can't be negative for any even numbered root.
Correct. You can't come up with 3 numbers multiplied together that will give you a negative number. When it's even. That is correct, sir. Very good. Nice job. All right, everybody good with those so far? Okay, so it does get a tad bit harder. Okay, a lot of these, not a lot of them, but some of these are going to ask you to round to the nearest tenth. Some of these are going to ask you to round to the nearest hundredth. Okay, because there's a lot of decimals under there. Okay, and now again, on your quiz, if memory serves me right, some of you missed them towards the end of the quiz last week because you didn't round correctly to the nearest tenth. That's like an elementary thing. Right? Now, the harder ones are when they give you something that looks like this, and they ask you what perfect cubes fall between that. Now, again, the good news is you're going to be able to use your calculator. Okay. So this comes out to be 4.4 something, something, something. Okay. So you're going to have to come out, or you're going to have to find a cube root of what two numbers? If you want this to fall in between, that's the question. You need to find the cube root of what? What two whole numbers? Grayson? 4 and 5, right. Correct. So what's the cube root of 4? 64. What's the cube root of 5? 125. Those would be your answers. Yeah, baby. That's what I'm talking about. Okay. And that's with them giving you a cube root that is an oddball. Okay. So far, so good. I'll assume your silence means yes. Yes. Which you will. I haven't made the quiz yet. I'm probably going to have either multiple choice or something along those lines, or you're going to have to do the math to figure out which one. But yeah. Similar? Oh no! There's no quiz on cube. No. All right. So looky here. Here's what I want to show you. Okay. Calculator. Does that look a little different? Okay. Now this is not your Desmos 4-function calculator. Okay. This is the scientific one. Okay. So if you just, I don't know, if you want to bookmark it, that's fine. You don't have to, but if you want to. Okay. Here's what I want to show you though. Do you see down here the little n? See the little variable there, n, with the check mark? Down here underneath AB. You see that? I'll see where that is over there? See how it comes up? See where the cursor is blinking? What are you always going to put in there? You're going to put a 3 in there, right? And then you're going to have to move your cursor over here, right? And it takes that little gray thing away. And we'll plug in 512 and look what it does for you. Gives you the answer over here of 8. That's the cube root of 512. Okay, so let the calculator do the work for you. We're not asking you to memorize cube roots. You don't have to. We're just introducing it. Okay, so let's plug in. Remember the 89, right? Now look what happens. See what comes up? 4.464745096er. Okay, and this is where you're going to have to read the question carefully. Am I rounding to the nearest tenth? Am I rounding to the hundredth? Am I rounding to the thousandth? Okay, because those questions are going to change. I mean, all you got to do is read the question carefully, look at it. Okay, what two squares do I have to find in between? I mean, it's like square roots. The more you do it, the more you're going to know what 512 is, 64, 289. You're just going to know. Okay. Michael, you have a question? Oh, yeah. Oh, absolutely. You'll be able to use this. Yeah. You'll be able to use a cube root calculator. Correct. Well, yeah, we want you to. That's not a That's not an option. Michael? Yeah, Michael?
Is lesson 12 the last chapter?
This is the last chapter. Why? Oh,
Also, how many is this? Are there only like 4 things of lesson 12?
you will have a quiz over real numbers or rational numbers, irrational, and cube roots. Tomorrow and Thursday we're gonna review. Friday, get a quiz, just like last week. And then we're moving on next week to something even better. Okay. Any questions on cube roots? Okay, so while you are watching the 2 videos that are on today's slides, okay, while you're watching those, I'm going to come around. I'm going to pass out a cube root worksheet, okay, that you need to do. Along with, you have an IXL on there, and plus you have a homework sheet. So we got plenty to do.